Welcome to our Chapter 5, Systems of Equations and Inequalities. Today in this video, we're going to specifically talk about systems of linear equations in two variables. We're going to discuss how to determine whether an ordered pair is a solution of a linear system or not. We're going to learn how to solve a linear system of equation, first by substitution and the second method by addition. We're going to identify systems that do not have exactly one ordered pair solution, that is, what type of solution a linear system of equation can have. And finally, solve problems using systems of linear equation. So let's start our today's discussion with systems of linear equations and their solutions. Equation in the form x plus by equal to c is called linear equation since both of my variable x and y is raised to the power 1. And when you graph a linear equation, you will always find a straight line. For example, y equal to 2x plus 1 is a linear equation because my variable x and y is raised to the exponent 1. And when you draw this linear equation, you will find a straight line. In our picture, this is a blue straight line. That is the drawing of this linear equation, y equal to 2x plus 1. When two such equations, that is two linear equations, together form a system, we call this system a system of linear equations or a linear system. And a solution of a linear system of equation always comes in an ordered pair. For example, negative 110 satisfies the system 5x plus y equal to 5, negative 5x plus y equal to 15. There are two linear equations together, it forms a linear system of equation, and negative 110 is the solution of this linear system of equation. Since both of my equations are linear, so when you draw both of the equations, you will find two straight lines. The red straight line is the graph of my first linear equation, 5x plus y equal to 5. And the blue straight line is the draw of my second linear equation, negative 5x plus y equal to 15. And the intersection point, the green dot, is the solution of this linear system of equation, which is negative 110. Systems of linear equation and the solution. There are two types of solution a linear system of equation can have. If the linear system of equation has at least one solution, then this system will be called a consistent system. But if the linear system of equation does not have any solution, then this system is an inconsistent system. Determine whether the ordered pairs are solution. For example, suppose we have this linear system of equation 9x plus 7y equal to 8 and 8x minus 9y equal negative 69. So we need to now determine if the ordered pair negative 3, 5 is a solution of this system or not. So in order to solve this problem, first take the first equation 9x plus 7y equal to 8 and plug negative 3 in for x and 5 in for y into this equation. And then solve this. After solving, we find 8 equal to 8, that is my left hand side is equal to right hand side. If my left hand side is equal to right hand side, then this ordered pair negative 3, 5 satisfy my first equation. Do the same for the second equation. Let's take the second equation and plug negative 3 in for x and 5 in for y. And after calculation, we also find negative 69 is equal to negative 69. That means after substituting this ordered pair negative 3, 5 into my second equation, we also find that our left hand side is equal to right hand side, which means this ordered pair satisfies my second equation too. Since this ordered pair negative 3, 5 satisfies both of the equations, that means negative 3, 5 is the solution for this system. Let's do one more example on this, just to be clarified. Consider the system 2x plus 3y equal to 17 and x plus 4y equal to 16. We need to determine if the ordered pair 2, 5 is a solution of the system or not. Do the same. Take the first equation and then substitute 2 for x, 5 for y, and after that we found 19 equal to 17. So my left hand side is not equal to right hand side. That means that 2, 5, the ordered pair, does not satisfy my first equation. Take the second equation and do the same. Plug 2 in for x, 5 in for y, and it gives us 22 equal to 16. So my left hand side is not equal to my right hand side. That means 2, 5 does not satisfy my second equation also. Since this ordered pair 2, 5 fails to satisfy both equations, so it is not the solution of the system. Just to remember that the ordered pair must satisfy both of the equations to be a solution of this system. If it fails to satisfy one of the equation or both of the equation, that means this ordered pair is not the solution of the system. Let's go how to solve a linear system of equations by substitution. We will try to explain it by step. So our first step is solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, you can skip this step. For example, suppose we are going to solve this linear system of equation by substitution. X plus y equal to 6 and y equal to 2x. So in our first step, we need to pick one of the equation and solve for one variable. But as you can see, our second equation, y equal to 2x, already in this form where we can find y as a solution in terms of x. So we can skip the first equation and we can just pick the second equation, y equal to 2x, which is already we solved for the variable y. Go to the second step. Now we are going to substitute the expression that we have found from our step 1, and we are going to substitute this expression into the other equation of our system, which will give us an equation in one variable and from which we can easily solve for the single variable. So we got y equal to 2x from our step 1, and now we are picking the other equation, x plus y equal to 6, and we are going to substitute the expression for y into this equation. So x plus 2x equal to 6. When we combine the like terms and then solve for x, we got the solution 2 for our variable x. In our third step, we are going to back substitute the solution that we have found in our step 2 into one of the original equation. And then we are going to solve for the remaining variable. You can pick any one of the equation from your system. Let's pick the second equation in this case, which is y equal to 2x, and substitute the solution that we have got for x into this equation. And then after that, we got that y is equal to 4. So our proposed solution is 2 and 4. In our last step, we are going to check our proposed solution and we are going to verify whether this solution is actually the correct solution for this system or not. So let's pick the first equation, which is x plus y equal to 6, and substitute 2 for x, 4 for y, and then after solution we got our left hand side 6 is equal to our right hand side, which is also 6. So this ordered pair or this proposed solution 2, 4 satisfy our first equation. Let's do the same for the second equation. Let's pick the second equation, plug 4 for y, 2 for x, and we got, yes, our left hand side is equal to right hand side, so it also satisfies our second equation. Since our ordered pair 2, 4 satisfy both of my equations, that means this is my solution of this system of equation. Let's do one more example by substitution method. This time we are going to solve 3x plus 2y equal to 4 and 2x plus y equal to 1 by substitution method. So first step, pick any one of the equation and solve for any one of the variable. Let's pick the second equation, 2x plus y equal to 1, and let's solve for y. After solving, we got y equal to 1 minus 2x. In our second step, now we are going to pick the other equation, which is 3x plus 2y equal to 4, and now we are going to substitute the expression of y which we have found in our step 1. So let's substitute this one. Now we have got a single equation in single variable, which is y. So whatever equation that we have found in our step 2, this is the equation. Now let's solve for x. So first we are going to apply distribution law, and then we are going to combine the like terms, and after that, if we solve for the variable x, we got x is equal to -2. Now in step 3, we are going to back substitute the solution of x that we have found in step 2 into any one of the original equation. So in that case, in that example, we pick the second equation, 2x plus y equal to 1, and now we are going to substitute negative 2 for x, the solution that we have found in our step 2, and solve for y. After solution, we got y equal to 5. So our proposed solution is negative 2, 5. In our last step, now we are going to check the solution. Pick the first equation, plug negative 2 in for x, 5 in for y, and we found our left hand side is equal to right hand side. So the proposed solution satisfies my first equation. Take the second equation, do the same, plug negative 2 in for x, 5 in for y, and we found that still our left hand side is equal to right hand side. So our proposed solution, negative 2, 5, satisfy our second equation too. That means that the solution set for this system of equation is negative 2 and 5. Now we are going to learn how to solve a linear system of equation by addition. First step, that if necessary, rewrite both equations in the form x plus by equal to c. For example, if we are interested to solve this system of equation by addition, our first equation is 2x minus 7y equal to 2, which is already in the form x plus by equal to c. Now our second equation, y equal to negative 20 minus 3x, we need to rewrite this second equation since it is not in the form x plus by equal to c. So we are going to rewrite the second equation, and after rewriting we find 3x plus y equal to negative 20. We just shift negative 3x from right hand side to left hand side. Now our second step, choose one variable and multiply both equation by appropriate non-zero numbers to make the coefficient of this chosen variable identical except the sign. For example, if we choose variable x, then multiply the first equation by 3 and second equation by negative 2, and after that we will find that the coefficient of x is identical but with opposite sign. So this is our first equation, and we are going to multiply this equation by 3. After that we find 6x minus 21y equal to 6. Let's pick the second equation. We are going to multiply it by negative 2, and we find negative 6x minus 2y equal to 4. So as you can see, after multiplying, the coefficient of x of our first equation is 6, and coefficient of x in our second equation is negative 6. So they are both 6 but with opposite sign. In our third step, we are going to add the equation that we have formed in our step 2, and this will give us a single equation in single variable, and then we can easily solve it. So this is our first equation after multiplying by 3. This is my second equation after multiplying by negative 2, and if we add them, my variable x will vanish, and we will find a single variable, negative 23y equal to 46 in variable y. And if we solve this equation, we found y equal to negative 2. In our fourth step, now we are going to back substitute the value that we have obtained in our step 4 into any one of the equation, and we are going to solve for the remaining variable. So let's pick one equation. For example, in that case, we pick the first equation, 2x minus 7y equal to 2, and we substitute negative 2 for y, the solution that we have obtained in our step 3, and we are going to solve for the x variable. And after solving it, we got x is equal to negative 6. So our proposed solution is negative 6 and negative 2. In our last step, we have to check the proposed solution whether this is our correct solution or not. Pick the first equation, plug negative 6 in for x, negative 2 in for y, and we found that left hand side is equal to right hand side. So it satisfies our first equation. Pick the second equation, do the same. Substitute negative 6 for x, substitute negative 2 for y, and we found our left hand side is equal to right hand side. So it also satisfies our second equation. Since it satisfied both equations, this is our solution of the system of linear equation, which is negative 6, negative 2. Let's do one more example to solve a linear system of equations by addition. In this time, we are going to solve this system of equation 4x plus 5y equal 3, 2x minus 3 equals 7 by addition. First step, rewrite both of the equation in the form x plus by equal to c. As you can see, both of the equation is already in the form x plus by equal to c. So we don't have to rewrite anything. Let's go to the step 2. If necessary, multiply either equation or both equation by appropriate number so that the coefficient of your chosen variable are the same except the sign. So this is my first equation and we're going to multiply by 1 and we got the same equation. This is my second equation and we're going to multiply by negative 2. After multiplying by negative 2, we got negative 4x plus 6 equal negative 4. As you can see, my coefficient of x in my first equation is 4 and the coefficient of x in my second equation is negative 4, which is the same except the sign. Now we can add those two equations. This is my first equation after multiplying by 1. This is my second equation after multiplying by negative 2. And after we add them, my variable x will vanish and we will find 11y equal to negative 11, which is a single variable, a single equation in single variable, that is y. Then we can solve this equation and we found y equal to 1. And then in our step 4, we are now going to back substitute the solution of y that we have obtained in our step 3 in any one of the equation. So let's pick this equation 4x plus 5y equal to 3 and then substitute negative 1 for y, the solution that we have got from our step 3. And after solving for the variable x, we got x equal to 2. So our proposed solution is 2 and negative 1. And in our last step, we are going to check the proposed solution. So pick the first equation, plug 2 in for x, negative 1 for y, and we found that left hand side is equal to right hand side. So this proposed solution satisfies our first equation. Pick the second equation, substitute 2 for x, negative 1 for y, and we got left hand side is equal to right hand side. So it also satisfies our second equation. So since it satisfies both of the equations, that means the solution of this system of equations is 2 and negative 1. The number of solutions to a system of two linear equations. So there is this table which shows you that some system of equation can have exactly one solution. Okay, these are if you draw this linear system of equation, the system of equation that has exactly one solution, you will find one intersection point. If my system of equation does not have any solution, that is a system of equation with no solution, you will find that when they are graphed, they are two parallel lines. If my system of equation has infinitely many solutions, those two lines, or when they are graphed, the two lines will be identical. They are the first picture shows a linear system of equation with one solution. The second picture shows a linear system of equation with no solution, that is two parallel lines. And the third picture shows a linear system of equation with infinitely many solutions. Example of a system with no solution. This is my system of equation 6x plus 2y equal to 7 and 3x plus y equal to 2. So if we here want to solve it by addition method, so pick the first equation, multiply by 1, you will have the same equation. Pick the second equation, multiply by negative 2, you will find negative 6x minus 2y equal to negative 4. As you can see, my coefficient of x in my first equation is 6, coefficient of x in my second equation is negative 6, which are identical except the sign. If we add this, my variable x will vanish and I will find 0 equal to 3. So this system of equation gives me 0 equal to 3, which is a false statement because 0 cannot be equal to the number 3. So since this produces a false statement, that means that this system of equation does not have any solution. So the solution set for this system of equation is an empty set. So this is an example of a linear system of equation with no solution. Let's have an example, a linear system of equation with infinitely many solutions. This is our system of equation 9x minus 3y equal to 12 and y equal to 3x minus 4. Now, let's apply the substitution method. Now we are going to unpick the first equation and substitute the expression of y from our second equation. And after that, if we solve this, we found 0 equal to 0, which is a true statement, which gives us a true statement. That means since while trying to solve this equation, we got a true statement. That means this indicates that this system has infinitely many solutions. So this is one of the examples of a linear system of equation with infinitely many solutions. Break-even analysis. So suppose a company produces X number of products and also sells X number of products. So if I want to find a revenue function, this is my formula that I can form a revenue function. R of X is equal to price per unit sold times X. X is the number of products and price per unit sold, that is the selling price of 1 unit of this product. My cost function, I can also generate my cost function, and this is the formula. C of X is equal to fixed cost plus cost per unit produced times X. X is the number of unit of this product that this company has produced times the cost for producing 1 unit of a product, which will be added to the fixed cost. So break-even point is the point of intersection of these two functions, that is revenue function and cost function. That means break-even point are those points where the cost of the products and the revenue of the products is equal. So basically at break-even point, my R of X, that is my revenue, is equal to my C of X, that is cost. So solution of this above equation will give you the break-even points. So let's do an example regarding break-even analysis. So suppose a company manufactures running shoes. So the fixed cost of producing these running shoes is $300,000. Additionally, it costs $30 to produce 1 pair of shoes, and they are sold at $80 per pair. Write the cost function C of producing X pairs of running shoes. So I can use the cost function formula, which is fixed cost $300,000 plus the unit cost of producing unit products, that is $30, times the total number of unit of products that this company has produced, that is X. So $300,000 plus 30X. Write the revenue function R from the sale of X pairs of running shoes. So I can generate my R of X is equal to 80, which is the selling price of unit product 80 times X, which is the total number of products, total number of unit of products that this company has sold. So determine the break-even point and describe what this means. So we can find the point by solving the system. R of X is equal to C of X. So we have already got our R of X, which is 80X, and our C of X, which is $300,000 plus 30X. So if we solve this equation, first we are going to combine the like term, that is X term, and then we are going to solve for X, which is 6,000. So then now we are going to substitute this solution X equal to 6,000 to any one of the equation, either R of X or C of X, both will give you the same result. So we are going to choose the revenue function, and we are going to substitute 6,000 for X, and we got for $800,000. So our break-even point is 6,000 and $480,000. And what does it mean? The break-even point is 6,000 and $480,000. So describe that this means that the company will break even. That means that the company cost and revenue will be equal when they are going to sell 6,000 pairs of running shoes, and when they sell 6,000 pairs of running shoes, their revenue and cost both will be $480,000. And by that, we are going to finish our today's discussion.